Hi, I thought I'd give you a quick 5-10 minute video on how to use overleaf and LaTeX. So first thing we have to do is type overleaf.com in your favorite browser. This will work on any platform, of course. And you'll get to the overleaf site. Now, I already have an account, so you'll have to create an account in order to use this platform. It's free, of course. So once you have this page, if you can get to this page, you should see new project. If you type new project, you can pick on blank project. All right, so I'm going to pick that. Then it wants a name for your project. I'll call it demo project. Okay, you might call it assignment 1 or assignment 2 or something. I'll create it, and it takes me to the working window. Okay. So what we have here are two panes, a left pane and a right pane. The left pane is where you'll do all your typing. The right pane is just what thing will look like if it's rendered as a say a PDF document. Now, although I asked for a blank project, it's not entirely blank. It already puts some stuff in for me. Now, for those of you used to Word or any things like that where everything is WYSIWYG, this may come as a bit of a shock. This isn't WYSIWYG. This is pure text. And it's almost like a computer language where you write your document in this form and then you compile it. And when you compile it, it converts all this ugly ASCII code, all this text code into a nicely rendered project. The reason for showing you LaTeX is because it's very widely used, and especially in the sciences and engineering. It also has made inroads into the humanities as well. Most journals accept LaTeX. A lot of books, textbooks, use LaTeX to write them. It's particularly good for writing very large documents. I mean, for example, I would never use Word to write a book. That would be so tedious. The nice thing about LaTeX, it takes care of a lot of things that you'd normally worry about. Things like the bibliography, referencing equations, referencing figures, things like that. So you can focus, the idea is you can focus more on the writing and less on the look of it. So let's have a look at this blank project it's produced. So there are a couple of sections to this. First section is the one at the end where you see begin document, end document. This is where you'll do all your typing, okay? So when you type your article or whatever it is, all your typing goes in there. In front of this is a thing called a preamble. These are things that that just need to be put in place. The most common things are extra packages or libraries. So just like in Python, you have import libraries. In LaTeX, you have something called use packages, and there are hundreds and hundreds of packages that do all sorts of fancy things for your document that extend the capabilities of LaTeX. This one here is a default one that's given to you. I'm not entirely sure. I thought, but anyway, it's basically what it's for is to make this more friendly for foreign languages where the lettering has accents and things like that. So see, I don't need to worry about that. What it's also done is put in a basic title page. The title page is defined. You can define it in the preamble or in the main document, but usually it's defined in the preamble. So you define the title, author, and date. And then in the document itself, wherever you want the title to come out, you go /make title. Now you've noticed that a lot of these things have this slash in front of it. It's a backspace or forward space, one or the other. This indicates a command, a LaTeX command. So /title means there's a title coming up. And whenever you need to give an argument to a command, you enclose it in curly brackets, okay? So it's /title curly, the title itself, and then close curly. So a lot of commands will take curly bracket arguments, sometimes more than one. The other thing you'll find is sometimes there's a square bracket, something in square brackets. Those are optional arguments. In fact, I'm going to add one optional argument to this. So you notice that the first line declares a document class. At the moment, it's called an article, but there are other classes like books and reports, slides like PowerPoint slides and so on. So we'll stick with article, but I will add the optional argument to increase the default font size to 12 point. Now, having done that, you may be wondering you don't see any change on this side. That's because you can either force a recompile. Okay, and you can see the font size has gone up. Or if you drop down the little green button, you'll see you can have auto compile on. And that means every few seconds or every time you make a change, it'll recompile automatically and render your project. But you can have either way. Now, inside the document itself, we see we got make title, and we got the first of something that you'll often use, and that is the section command. This basically uses a larger font that represents a section, and you can see the subsection here. It also numbers it automatically for you. So here we have section 1. I could have another section underneath. Let's say I got some text here. All right, just put some text in. Then I have another section. Maybe I'll call that methods. Okay. If I compile this, you'll see now I'll have 2 sections, section 1, introduction, section 2, methods, and so on. Okay. There are also subsections, a subsection, okay, and there are subsections, and then there are paragraphs. But if I compile this, you'll see what happens. You get a smaller font, right, a subsection, and now also the numbering has add an extra layer to the number, which is 1.1. Okay, now of course one of the main uses of LaTeX was why it became popular in the first place was its ability to render math equations. You might find the syntax a bit odd, but to start a math equation, you use slash square bracket. Then you put the math in, x plus y, and then close it off. Oops, close it off with a square bracket. So if I run this, you'll get the equation. All right. Now the equivalent to this is, but for some reason it's no longer recommended to use. I don't know why, but I still use it. Is the dollar sign, and dollar is equivalent to this. So this notation is called a display math equation, which means that it gets put onto its own line and centered. So let me run this. You'll see I get they're exactly the same. So this notation is exactly the same as this notation. But for some reason, they recommend no longer using this, but only use this. I don't know why, but I mean it still works, as you can see. So what happens if you wanted some math in the middle of a piece of text? So this is my equation, right? Now for this, you don't want a display equation. You want the equation to be embedded in the text. Then you use a single dollar, and then I'll put, let's put minus y instead, okay? So I recompile this, and now the equation appears in the text itself. One of the nice things about LaTeX is it understands the sizes of the fonts and so on, so that you don't get weird line spacing. If you have a fat equation, Word tends to be really bad at that, where you get different line spacing within a paragraph as it tries to fit an equation. That won't happen here. It'll adjust all the line spacing to make it look consistent, which is much nicer. So what about other kinds of equations? Well, let's show you what we can do. So let's see, I'll do a display equation. Let's say I wanted to do a derivative, let's say dx by dt. So I could either do that, dx by dt, which is okay, but it doesn't look great. If you wanted an actual fraction to look like a fraction, you use slash frac, and then there's 2 arguments, the numerator and the denominator. If I run this, you'll see it gets rendered, the way you might expect. By the way, the new Word, especially Word 365, actually supports the LaTeX syntax for doing equations. So if you type this in the new Word, you will get that kind of rendering dx by dt. Okay. So we can carry on. I can go, it's maybe it's 2x squared. To do the squared, I just do a hat. Again, this is recognized now by Word. And then maybe minus, let's do a sign. I'll show you something there in a minute. Let's say 3x. Okay. And I compile this. You'll notice that the sign has been rendered in italics, which is not standard practice. So in order to make it, in order for it to recognize this is actually a sign function, you put, there's actually a sign function /sign. And when you do that, you get a proper rendering of the sign. Okay, now it's using upright letters instead of italics. You can do, of course, integration. You can have your limits like that. X squared, let's just do that, equals 0 or something silly like that. Then I recompile that, you'll get an integral. All right, so to do integral, you do int/int. And then the underscore here means that's the subscript, which is I equals 0. And then the hat here, n, is the superscript n for the limits on the integral. Okay. Now, a common thing you might want to do is to include images or figures. Now, to do that, you have to actually use a package. So there's a package called GraphicX. In fact, it knows about it already, called GraphicX. And that gives you a new command called /include graphic. So /include graphics. And the way you do that is you go include, because it knows already. There's a couple of arguments here. There's a set of optional ones, and then there's the one you have to put in. The one you have to put in is the name of the image, right? The image file. And the one in brackets, you can do things like scaling the image and so on. So let me find an image. So in order to use overleaf for the images, you have to upload the image. So you need to get an image from somewhere. Okay, so I'll go here and I'll select one from my computer. Let's see what we have here. Do we have anything suitable? Oh, yes, here we go. So on the assignment I've got, let's say include a non-inverting, actually, no, I want to do, let's do the tank, right? Notice I can either pick PNG files, bitmaps, or PDF. All right, if you're going to go for a publication, you should use PDF. So let me select PDF. That gets loaded up, and now that's there now in my list of files. Okay, so now I'll put dual tank PDF. Okay, let's run that, see what happens. It might complain actually, but we'll see. No, it didn't complain. And there you can see that's the double tank model. Now you might think to yourself, yeah, that's a bit too big. I really need it smaller. So what you can do is you can go in here, type scale equals say 0.2. That'll make it much smaller. Let's recompile that. Okay, and yeah, well, that's a little bit almost too small now. So let's take it up to 0.8. So as I said, this is not WYSIWYG, which may come as a bit of a shock to some of you. But you have a lot of power here when you run these kinds of scripting languages, which is why they're popular. What happens if I wanted to put a caption in? Well, a caption is associated with a figure, so I need to create what's called a figure environment. Okay, so begin figure, end figure. Now, if I run this, it's rendering it as a figure. You don't see any difference yet, but let's put a caption in, shall we? Caption. This is my tank model, right? Full stop, close that. And now, if I compile it, I'll get a caption. Now you may be thinking, hold on, it's off center though. I want it in the middle. I don't want it to the side like that. Okay, then you go centering. If I remember right, and it should center it for us. There it goes. Okay. You may be thinking, yeah, but I need to cite this figure in my text because what I'm going to do is I'm going to say this is my equation and I refer you to figure something. Okay. So what I can do is I can put a label on this figure. So let's call it something fig. You can put whatever you want here. I often use fig : to recognize this is a figure label. I'll call it tank. Okay. So what I do now is I take this label, take it up to here, take it up to figure, and I say reference my figure. Okay, now you notice there's no space though here, and I really need some space. But to stop it adding any too much space, I'll tell it I just want one space between figure and the reference itself. So let's run this. And hey presto, I get this. This is my equation, and I refer you to figure 1. So this is how it keeps track of figures. You can do the same thing for equations. And other things. There are other things as well you can reference like that too. So I think that is probably. Oh, a couple other things you might want to do. What happens if you want to make something bold? Let's say I want to make refer bold. I just put refer inside some curly brackets and then put / bold font in the front there. When I compile now, my refer is bold. It is bold, even if it doesn't look quite bold. There's things like underlined, emphasize, which basically makes italics. Actually, let's do that, shall we? Let's make the rest of it in italics, called emph for emphasize. And I recompile that. And I get U is in italics. Let's write some more text here. Here is some more text. What happens if I wanted to make some bigger text? Right, so that's a bit on the small side, I might think. So let's recompile this so you can see how big it is first. So here's some more text. What happens if I wanted it bigger? Well, to make it bigger, I can go large. So everything inside the curly brackets, get rid of that one. Everything inside the curly brackets will now be large. And there it is. And there's even bigger ones. There's large with a capital L, which is slightly bigger again. And there's, I think there's large all caps, or maybe I'm wrong there. I know there's huge, right? There's even bigger. And there's huge with a capital H, which is probably the biggest, I think. Maybe not. Maybe it's huge. I can never remember these things. I always have to look them up. Oh, no, I didn't like that at all. So huge. There you go. Huge is the biggest one, I guess. You can go smaller as well. There's small script size. The normal size is called normal size, and then there's tiny. There's a few others that you can. Let me see if I can find the font list size LaTeX. Let's see. Oh yeah, here we go. So here they are. So we have tiny, script size, footnote size, small, normal size, large, large. Oh, there is large with all caps, and then there's huge. Okay, so you can get different sizes like that. You can be more precise if you want by using actual point sizes, but just makes it more human friendly, I guess. These words. Okay, so I think that's it. Let me see if there's anything else. I guess there's one other thing we could do. Let me get rid of some of this. Let me get rid of all this. You might want to do lists. So let me grab one here that I've already got. So this will give you a bullet list. All right, so I'll compile that and you can see what it looks like. So to create a bullet list like this, you begin itemize, and then inside here you have all the list items, and then end it with end itemize. And then inside there, each time you want a bullet point, you go /item and then the text. Okay. Now, if you wanted it numbered and not using bullets, you can use the enumerated list instead. This is very similar. Instead of itemize, it's got enumerate. So if I compile this, you'll see now these items are now let's recompile. These items are now numbered, so 1 and 2 and so on. Okay. There's support for tables, and you can do all sorts of fancy things with borders and colors, and there's a fantastic plotting package called PGF plots There's a drawing package called TickZ, although it might be easier just to draw the stuff outside in a drawing application than just load it in as an image. But the plotting package, the plotting package is quite impressive. Does 3D and 2D, bar graphs, lines, all sorts of stuff. What else? Oh, I think that's it. I think for now. Okay, hopefully that gets you started. Okay, and there's masses of stuff online, of course. Okay, bye now.